Hello everybody, this is the first of two secant tangent videos. This particular one is where we will investigate the lengths of those secant and tangent segments. So I've taken the liberty of drawing a secant segment and a tangent segment, making sure to use the tools that are over here on the left side of GeoGebra. And if we're remembering the secant-secant relationship, the links that we were concerned about were both links that emanated from that exterior point, in this case C. So those are the two links that I have up here. So let's go ahead and go into our calculate tool and see what happens. When we had the secant-secant relationship, we looked at the product of those two links that came from point C. So in this case, those are FC and EC. So let's see what happens when we take FC, equal sign, and multiply times EC. Well, we get 48.5. Well, when we look at this, DC is 7. So, it's kind of close to 48.5 if we square rooted 48.5. So, if we move this around, maybe try to get some whole numbers, well, 9, and 81, hey, that looks like something. So let's see what happens when we go ahead and take DC and just square it. Yeah, of course, we got 81. Now, when we move point C around, look, those two numbers are the same. We can make our circle bigger. Those two numbers stay the same. We can move point A, and those two numbers stay the same. So it looks like the product of these two secant segments is going to equal the square of the tangent segment. The product of these two secant segments is going to equal the square of that tangent segment. So if we look at the diagram that you were given on your worksheet or in your packet, and we go ahead and think of how we would express this, it looks like we're going to take W and square W, and that would be equal to that length Y times the entire length Y plus Z. Okay? So sure. Oops, give me 1 second. There we go. I just wanted to make it bigger for everybody. So it looks like, that's too big, isn't it? It looks like the square of the tangent segment is equal to the product of those two secant segments emanating from that common external point. So the square of the tangent segment is equal to the product of the two secant segments.